How to read the capacitance value from the code on the capacitor. Deciphering the cryptic codes adorning capacitors unlocks their hidden capacitance values. Often, a 3-digit system reigns. The initial 2 digits stand tall as the significant figures, the core numerical value. The third digit then steps in as a multiplier, dictating the power of 10 to be applied. For instance, a 472 isn't just 472, it signifies 47 multiplied by 102, yielding 4700 picofarads, PF, neatly convertible to 4.7 nanofarads, NF. Occasionally, a simpler 2-digit code emerges, where the digits directly represent the capacitance in picofarads. A humble 33 thus translates directly to 33 PF. Adding another layer of information, letters often accompany these numerical codes. These alphabetical companions can denote tolerance, the acceptable deviation from the stated value. Common examples include J for 5%, K for 10%, and M for a wider 20% range. Beyond value and tolerance, units are paramount. Keep an eye out for PF, NF, or F printed alongside the code, as these directly indicate the scale of the capacitance, preventing misinterpretations. For smaller values, a letter R might sneak in, not as a tolerance but as a decimal point. Thus, 4R7 signifies a capacitance of 4.7 PF. Furthermore, capacitors often carry voltage ratings, sometimes encoded with letters. Recognizing these is crucial for circuit safety, preventing capacitor failure due to overvoltage. When in doubt about a voltage code, consulting the manufacturer's datasheet is always the wisest course. Finally, remember that polarized electrolytic capacitors will prominently display a polarity marking, usually a stripe of minus signs, guiding correct connection in the circuit. Understanding these visual cues transforms a seemingly random jumble of characters into a meaningful specification of a capacitor's electrical properties.